So my name is Will Nixon. This is the Charge Tape Lab 1 for Physics 2212 or Physics 2. So, all right, so for key concepts, in this lab we're observing and modeling the forces created by charge tape on other objects and other charge tapes. In order to calculate these charges, we're using principles such as Coulomb's law and our equations for the electric field. And Coulomb's law defines the relationship between charged particles and the forces they enact on one another. And electric field theory says that electric fields are present around objects with charge, allowing electric force to act on charged objects which are not in contact. So we're going to be using both of those concepts in this lab. So yeah, the purpose of the experiment, add charges to pieces of tape, observe how these charges interact with each other, familiarize myself with the idea of charges, and draw conclusions about the charge based on interactions between several charged objects, calculate models, and make models of the experiment in GlowScript. Here again are the fundamental principles. These are the equations that I used. Coulomb's law, you can see here is, it's a equation for the force of the electric force of a charge based on one charge's location and the charge that's acting on that charge, and you see that in the top right corner. The electric field equation again is only focused on one charge, so there's only one Q in that, and gravitational force is force equals negative mg. Here's the calculations that I had, some of the values that I obtained from my materials and the calculations I had. Observations. So charge tape A in the bottom picture moves closer and closer to charge tape B in order to enact a force on charge tape B, which is pushing it up. And in the lab, we measure the distance from A to B, or the distance from A to B is where that displacement of charges is arising. So here are my computational models that I created in GlowScript. The first model describes forces on the top tape characterized as a single point charge. You can see that it's only 1 point there. And then the second model is two charge tapes characterized as a line of charged particles. And my code for that is here. The first model seen right here is a model for the single charge particle, and the code at the bottom there is the model for the line of particles. As you can see from the results that I put on the left-hand side, electric force in the second code is much less than the output for the first code. And then you can see in my code how I use the proper formula in each code segment to determine force values for that. For assumptions, you assume that the long tape can be treated like a point charge with all the electric charge concentrated at the center of the tape. And then you assume that each U tape had the exact same amount of charge distributed evenly across the surface. Both of these aren't really true in real life at all. Obviously, a piece of long tape isn't going to have a charge located at a single point, and the U tape is probably not going to have the exact same charge. For the no air resistance assumption, that assumption can be ignored as both pieces of tape in this experiment were static. And here are discussion questions. What would happen if all protons become negatively charged and electrons become positively charged? Nothing would change. This question represents a change in physics convention rather than physics phenomena, so none of the actual experiment would change. And for question 2, why should charge tapes be handled as little as possible? If you touch a piece of charge tape too much, charges can flow from the charge tape into your hand, causing the charge in the tape to go away, and that would kind of ruin our experiment. And yeah, that's it. Thank you.